Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy, or we show you how to navigate space. We're here on Friday nights at 9 p.m. Pacific Time, 10 p.m. Mountain Time, 11 p.m. Central Time, and midnight Eastern Time. We're broadcasting live from Thousand Oaks, California. Thanks so much for joining us. Our topic tonight is Planet 9, and we're going to talk about a few nights this coming week. With that, I'll turn it over to Jeff. He's got the Planet 9 scoop for us.
Well, last time, a couple weeks ago, I talked to you about Planet 4, which is a Zooniverse project. And this time it's Planet 9, which apparently they just recently changed to be Backyard World's Planet 9. Okay. It's another project helping scientists find useful things in photographs. Can you share screen?
Oh, yeah, sorry.
Thank you. And here it is on their projects list. And you'll be looking outward from the sun at star fields looking for moving objects. And this is basically an example of the types of photographs that you'll be looking at. I don't think that these are from a set, just these are 3 example photos.
Okay.
You'll be looking for 2 different types of objects. Brown dwarfs, which is right here, just a little bit bigger than Jupiter, which are apparently closer than I thought. They say that the nearest star is not Proxima Centauri, but one of the many brown dwarfs that may form swarms around the solar systems. The other is Planet 9. Ta-da! This is a planet that has been theorized because of the orbits of several Kuiper Belt objects. This is the same thing that got us searching for Pluto in the first place. In fact, you'll be searching for both types of objects the same way that they looked for Pluto.
Clyde Tombaugh discovered Pluto in 1930 doing this.
Mm-hmm. Yeah, comparing images and looking for dots that move. In fact, here's Pluto, the kind of the smallest dot in that region, which moved over to here to be kind of the only dot in that region. But it definitely moved past this pair of stars here. And that's how they found Pluto. And this time it'll be with false color images that are supposed to help you spot the moving dots and dipoles. I don't know that that it really helps all that much, but it might. To me, white on black certainly was a lot clearer on the Pluto image. If you take a look at there versus there, but these are probably higher res images, so maybe this helps if there's just a lot of stuff, showing up there.
Okay.
The dipoles, here. The dipoles are objects that are bright on one side and then bright on a different side. Yeah. Each set of 4 frames, each set is 4 frames that you can look at individually and run as a movie. And here's the second frame of the shot, and you can see dipoles up here. If you look at how they change the brightness from one side to the other. In this case, I found 4 objects that look like dipoles. I show 3 marked here because the one in the bottom left corner here looks like one too, and I marked it after I took the screenshot.
Mm-hmm. Okay. And that flipping back and forth is exactly what Clyde Tombaugh was doing to discover Pluto. He was looking for changes.
Well, maybe I'm sure.
Oh, sure. I didn't know if you were done or not.
Yeah. And in this case, they run a movie of 4, so you can definitely see changes. I actually haven't seen a mover in these. I've seen only dipoles.
Okay.
Maybe just because this batch is, or Just haven't gotten lucky to see a mover.
And what was the significance of the dipoles? I don't remember.
I don't know either.
Oh,
I just
okay.
know that we're looking for them.
Got it. So we've got two things to look for with Planet 9.
Mhm.
And one of them is like if something kind of skitters across the screen compared to all of the stars that are stationary, or basically appear stationary, and then these dipoles.
Right.
Okay.
And they say that humans are actually better than machines at figuring this out because humans can filter out noise.
Oh, okay. And we definitely are good at pattern, seeing patterns. Let's see if we have a question here. Oh, yes. All right. And thanks so much for asking. And hi, Michael. We're really glad you're here. Kishore from Bangalore. So glad to see you. My question is, why is Pluto different from the other planets, and is it it's too cold? Let me see if I understand this. You want to know why Pluto's different and why is it so cold?
Yeah, why don't they call it a planet?
Tell me if I'm wrong. I would love to know.
Yeah. Well, first off, why they don't call it a planet is because they decided that one of the criteria for something being a planet is that it cleared its orbit. So there's nothing else competing in its orbit.
Right. No other debris.
Because otherwise, Ceres could be considered a planet. It's in the asteroid belt.
Okay.
In fact, for a couple of years there, it was called a planet.
Oh, no kidding.
Yeah.
I didn't know that.
Because it was big enough to be spherical.
Okay.
And that's one of the other criteria, is that it's big enough that gravity pulls everything in to make it spherical.
Oh, great. Okay.
And then the other one is that it orbits the sun and not something else. That's another one.
Okay. So, Daniel, thanks for joining us. And his question is, don't they have AI that can find these objects? And he says goodies, but I'm going to say objects.
Yeah. Probably, but they found that, from what I've read, I don't know all of it, but from what I've read, humans are just better at filtering out the noise, at seeing the patterns that, okay, this looks like something, this doesn't look like something. And
I was reading it. It sounded like it was like kind of our brain processing power is very good with, in our eyes. They do a lot of the things that need to be done to detect these particular things.
Well, our brains are designed for pattern matching.
Yeah, absolutely.
I mean, that's what we're good for. And yes, eventually AI will be able to do it. But, quite frankly, unless you have data to train the AI, which means a bunch of people finding these and then showing it to an AI saying that, hey, these are what you want to look at, not the other ones. That's how you train the AI.
That makes perfect sense. All right. Did we help you out, Daniel? And Kishore, if we answered your question, if hopefully we did. And if not, go ahead and ask.
The second part of his question, is it too cold?
Oh, yes, right. Oh, it's too cold. Yeah.
There's nothing too cold to be a planet. I mean, that's not one of the criteria for a planet. And yes, it is really cold. Yeah. I mean, it's, it's apparently it sometimes warms up enough that some of the frozen ices become, volatile and form a gas, and it has an atmosphere during some portions, some time periods, and then doesn't in others. But the gases that we're talking about are like hydrogen. I mean, it's got frozen hydrogen on it. That's like, it's really cold.
And as you were speaking, it made me wonder, does that same thing happen on Pluto as happens on Mars, where it kind of sublimates and then seeps through the cracks? Are we going to see that as well on Mars, on Pluto at some point?
Well, we did see, when we did the flyby, we did see a lot of different interesting surface features. It's not just a ball. Mm-hmm. There's a lot of interesting stuff. So it is volatile. There is stuff happening on it. And it's not getting much energy from the sun, but apparently enough to kick off some hydrogen every once in a while. And that's, so it makes it a very interesting thing that's really hard to get out to see too much of.
And he says, thanks for answering about Pluto. Oh, nice to see you too. Hope we're doing good. Thank you very much. Oh, yes. What is the Kuiper Belt? Ooh, good question. Thank you.
Okay, it's a whole bunch of basically mostly frozen ice balls that are of various sizes, stuff left over from the formation of the solar system. Basically, too far away to get drawn into anything else.
Mm.
They formed clumps, dust formed clumps out there, and is just a halo around the solar system.
Yeah, kind of a big sphere, right?
Yeah, in fact.
And I know the sun, when it forms, it's sort of, as it's going through its process of becoming a star, it will be, a big, and everything in the vicinity gets blown away unless it's heavy enough to stick around like the planets.
It's not an explosion, but it is like a strong wind.
Oh, okay.
So it blows the gases out. And that's why the gas giants are far out, the rocky planets are close in.
Okay. I hope that helped, Kishore. If you have more questions, absolutely let us know.
Yeah, if you re-show the screen.
Yep.
This was one of the slides that I had, but a lot of these things are Kuiper Belt objects, but the whole Kuiper Belt is kind of like in this area. And if you see Neptune's orbit, which is right there.
Wow.
This is kind of the Kuiper Belt. It's really far out.
The Kuiper Belt is very far out. Okay, because Neptune is very far.
Yeah.
All right. Anything else you want to show?
Nope, that's it.
All right. And we did have another question from Daniel. Thank you so much. And how often does our solar system attract objects versus losing them? Do we have a way of knowing? Ooh, that's a really good question. Thank you, Daniel. Any idea?
I don't think we have a way of knowing. For one thing, we can't see everything. And
I think, in terms of like astronomy and space and stuff, timelines are very long and humans don't live as long as timelines. And it's only been about 400 plus or minus, years that we've been kind of tracking things. And of course, orbits can be very long. And then, when things come into a system, that could come from very far away. And we just don't have the type of time scale yet as a species to kind of figure that out, I don't think. But what's your thought on that?
If I were to guess, I would say that we expel things a lot more than we attract them, simply because it's so far from anywhere else.
Oh.
The chance of something being pointed in our direction and actually getting close enough to us to be attracted is pretty small. But Jupiter is always tossing stuff out. I mean, something that gets too close to Jupiter either gets pulled into the sun, tossed out, or, some other orbital, monkey shines. Some of the things that we attract don't actually stick around. They just fly through because it's kind of like mama bear, Papa bear, baby bear, mama bear. It has to be just right to stick around. And some of the things that I think that we attract are things that we kicked out, and we're not actually attracting them. They're just on a really long orbit.
Ah, okay. And like in terms of the whole galaxy, we live out in the boonies, essentially. And I love learning about Orion's arm. We live on the arm that includes Orion, the Orion constellation you see in the night sky. And I thought you did have one more piece here for your part.
Yeah, we got distracted. Basically, this Planet 9 project is only 14% complete.
Got it.
Whereas, Galaxy Zoo was like 90-something high percent complete. And the Mars one, Planet 4 that I showed you before was 0% complete. This one's 14% complete. So it has been worked on, but there's still a lot to do. So there's a lot for people to look at on it.
Yeah, if you're bored and you need a project, this sounds really exciting. We did get another question. You ready?
Sure.
All right. So Kishore came back and said, why are days moving faster and faster? Are there any change in the Earth's revolution? So we're actually going slower. The rotation used to be 6 hours, right? Wasn't it 6?
Well, in the very, very beginning, yeah.
Yeah, when the Earth was a molten ball, long time ago.
And actually, it's the moon that's slowing us down. Basically, the drag of pulling the moon around has been taking energy from the Earth's rotation.
Oh, okay.
Because the moon is tidally locked, and it just basically it's just something. Energy doesn't come from from nowhere, and so it is taking energy now, and the moon is using that energy to actually move out.
Right, about 1 centimeter a year, the moon is just a little farther away every year.
And the Earth slows its rotation by like a small fraction of a second every year. A very small fraction of a second every year.
So we're going to have 366 days at some point?
Yeah. Yeah. And the moon's going to be too small to actually fully cover the sun in a eclipse.
Oh, right. Yeah. We're at a very special time when we can actually see a total solar eclipse where the moon and the sun, between their distance apart from, away from us, as well as their sizes, the moon can obscure the sun completely. But at some point, it will no longer be able to. They'll all be annular eclipses. All right. So with that, I'll watch for more questions, but I did want to make sure we tell people what they can look for this week. And it is a little bit quiet, but there are some pretty cool things. And let me tell you about that right now. So we're talking about between tonight, the 12th of February, and the 19th of February, which is next Friday. The moon is 1 day old, and the first quarter moon is on the next Friday, the 19th. Mars is still really high in the sky, and it actually kind of looks orange to me, but I think that's because it's been really close. In fact, several of the spacecraft that have been traveling to Mars are about to land on the red planet, and they're from several different countries. We know that Vesta is still something you can see in the night sky, and it's a 6.3 magnitude object, but you want to use binoculars to see that. You're going to look for it kind of after the sun sets in the east. It's going to rise with Leo. It's going to show up in the tail of Leo. But it's going to get easier and easier into March and so on. And I don't know exactly how long Vesta will be visible, but I've never seen, God, what are they? I'm losing my words. It's not a planet. It's not.
Asteroid.
It's an asteroid. Thank you so much. I've never seen an asteroid through a telescope or binoculars myself. I think that'd be really fun to look for. So it's going to get easier and easier. And I say, try it out. February the 13th, Mercury and Jupiter are in conjunction. And this will be in the early morning in the east before sunrise. Also on February 13th, Neptune and the moon are in conjunction. This is not a naked eye object, though. Neptune will not be visible naked eye. You will want something to help you out, binoculars, telescope, but it's going to be very low in the west, right as the sun sets. On February 17th, you have Uranus and the moon are in conjunction, and Uranus is also not a naked eye object, but it'll linger a little bit longer because this, as the moon goes across the sky, it's going to be higher and higher, and it will take longer and longer to set until we go full moon. I got another question. I'll answer that in just a minute. Unless it's part. Let's see. Okay. Oh, this is a good question. I'll ask it when I'm done with this. Alrighty. So let's see. Where are we? Oh, February 18th. I'm almost done, Kishore. February 18th, Mars and the moon are in conjunction. And again, Mars is way high in the sky, and it's going to linger for about half of the night. So you'll be able to see both of them together for about half of the night. On February the 19th, the moon will be between the Pleiades star cluster and Aldebaran, which is the alpha star of Taurus. All right, and that's what I have for this week. I'm going to go ahead and show Kishore's question, and we will talk about that. You're very welcome. And we want to talk about solar winds, why it will affect less electricity, the electric grid on the Earth. I love this question. You want to field that, Jeff?
Sure. Solar wind is just basically stuff given off by the sun. Think of steam coming off of a boiling pot. Basically, stuff on the outer shell of the sun gets hot enough that it gets ejected by the sun. It reaches a velocity that's higher than the sun's gravity can hold it in. So it reaches escape velocity. And the sun is so energetic that there's constantly stuff streaming off of it.
But very often it kind of comes back in, right?
Right, yeah. And solar prominences are just basically magnetic lines in it, pulling stuff and dropping it down. If they break, you get a coronal mass ejection, and that's what affects our electric grids.
Right.
That's where a whole bunch of that stuff. And the reason why it affects stuff is because usually the stuff on the outer edge of the sun is a plasma, which means that the electrons are stripped out of it, which means it's electrically charged.
Okay.
And you can see the effects of the solar winds as the auroras, because the Earth's magnetic field protects the Earth from the charged particles. But the magnetic field is kind of this shaped on the Earth, and so it gets close to the Earth on the two poles.
I think it's like a donut, though, like a toroid shape.
Right, it's a toroid shape.
So imagine a donut with a hole in the middle.
Right, yeah. But so at the poles, you can see the auroras. That's actually the solar wind for the most part. There's a little bit else going on there, but that's mostly the solar wind and the charged particles hitting the field and being drawn in and coming down to there. And
that's why it's at the pole, too.
Yeah, and most of that has no effect on our electric grid. Now, when you have a coronal mass ejection, that's so much of that stuff that if it's heading your way, which, I mean, there's a lot of space out there. We're 93 million miles away, and we're, this big compared to, the sun. So the chances of it hitting us are small. But if it does, that's enough of that mass. Think of solar wind exponentially bigger. It's like plus on that solar wind. So it all hits at once and is enough to actually get enough of it through the magnetic field to affect things here. And it's just basically a bunch of charged particles, and the electric grid is like a giant antenna. Antenna is a long wire that takes, changing electric field or magnetic field, and then collects it. Well, electric grid collects all that, and if it doesn't have somewhere to put it really good, it fries. Basically, capacitors blow. You get transformers that blow, and you lose enough of those, and then it starts cascading this.
Yeah, it can be really bad. Thanks so much for the question. Really appreciate that. And absolutely, if we need to explain some more, let us know. If you have another question, we'd love to help you out. All right, so if you are someone that's kind of it for our show tonight, unless you have more questions. If you are someone has done something interesting involving space exploration, science, or astronomy, we would love to share our show with you or your friends. And just so you know, next week is February 19th. We are going to have another version of the citizen science projects. I'm going to talk about Micro Observatory. It's a great place. You can use telescopes, swing around, and take pictures for yourself.
From your own computer, right?
From right from home, yeah. And we do have a guest lined up for the 26th. We're going to be talking to Allison Klessman from Astronomy Magazine. She's going to be with us that night. I did see we have another question. Let's go ahead and show that. Thanks, Daniel. All right. When will the magnetic field flip? Ooh, that happens on a regular basis, I understand. Yeah. Thanks, Daniel.
I don't know. I think it's one of those things that gets more likely and more likely with time, but it's kind of random. So it's going to happen. It's going to keep getting more likely to happen until it does, or it doesn't, and then everyone rewrites their theories. But I suspect that it will.
Awesome. We got another couple of thank yous. Really, really happy you're here to talk with us, Maria and Kishore. So you're very welcome. So yeah, unless anybody has another question, I think we're going to stop it there, and we'll talk about Micro Observatory next week. And the week after that, we'll have Allison Klessman as our guest from Astronomy Magazine. I can't wait to talk to her. Oh, she sounds like a really neat lady. Yeah.
And Kishore, commerce graduate, huh? Well, I'm an econ major and MBA, so there we go.
Right, yeah. So yeah, find Jeff online. He'll be able to comment to you, no problem. In the show after we've published it. All right, last call for questions, and then we're going to wrap it up. If you do have a question and we didn't get you here, we will go ahead and answer you actually in the Facebook chat. Okay, you're very welcome, Daniel. Thanks so much for joining us.
Yep.
See you next week.